Good morning friends, I hope everyone is doing well. In this video, we will discuss about complement of a language and how to complement a DFA. First, let me discuss what is meant by complement of a language. Let me take this one. We have a L1, language L1. We will discuss about the construction of DFA, all these things. First, let me discuss about how to complement a language. A language L1 consists of strings where number of beats are even. Is it clear? So, they are saying that alphabets A comma B is there. Okay, the language L1 consists of strings where number of B's are even. There is no restriction on the A's. So A's can be anything. So if you have two A's, no problem, but you should have even number of B's. And you can have AA, okay, and you can have that two B's. You cannot have 3 B's. That is what means 2 B's you can have, or you can have 4 B's, A 4 B's, okay, but AB is not allowed because the number of B's should be always even. So it can be even number of B's should be there. So AA BB can be there, AA can be there, BB can be there, BB BB means 4 B's can be there, A single A followed by 4 B's can be allowed. So always the number of B's should be even. So now what is meant by complement of the language? Complement of the language, let's take that if I say L2 is a complement of the language. Then what I can say complement? Just I will add not even. Okay, not even, it will becomes a complement of the language. So how I can write L2 is a language consists of strings where number of B's are not even. What is meant by not even? If they are not even, what I can say? They are odd. Okay. So how can I generate the language? If I see that the language will be L sigma star minus L1. Okay. L2 is equal to sigma star minus L1. Why? The sigma star is a clean closure. Clean closure on alphabets A comma B will consist of all the possible strings over A comma B. From A comma B of all the possibilities of sigma star, if I subtract L1 means the language. What is the language consists of? The strings where the number of B's are even. From the whole set of strings which are possible on alphabets A comma B, what is the sigma star represents? It represents sigma is nothing but A comma B. Okay, on A comma B all possible strings we can generate. Out of those strings, if I subtract or if I remove the language L1 means the strings which belongs to language L1, if I subtract, then I will get the strings where number of B's are not even, meaning is that I will get odd number of B's. We will check it. How can I represent the language L2 simply? The number of B's should be odd. So it can be a single B can be there. Okay. It can be AB can be there. It can be BA can be there. Okay. It can be A triple B can be there. Okay. You can have AA single B can be there. So if you see this, it will have a language L2 which does not belongs to language L1. So if you see that B does not belongs to language L1, AB string will not belongs to language L, BA string does not belongs to language L1. So what I can say that L2 is a complement of language L1. So how can I mathematically represent the complement is L2? If I want to say that it is a complement of L1, then sigma star minus L1. Okay, so this is the representation. So simply I can say that the strings which belongs to language L1 will not be there in the language L2. Okay, so now we will discuss about the DFA. Is it clear? How can we construct a DFA or minimize a DFA for language L1? Then how can we construct the minimize DFA for language L2? Okay, or from minimize DFA of L1, can we find a property such a way that directly we can construct DFA for L2. See, my objective now is that first I identified what are the strings belongs to language L1, and then I identified what are the strings possible on the long ways L2. Now I want to construct the minimized DFA for long ways L1, and I want to construct the minimized DFA of L2. These two things I want to do. Okay. Now while doing it, if I will check the possibility, I will check the any relation I can find between the minimized DFA of long ways L1 and minimized DFA of long ways L2, and then we will discuss what is that property. If you can construct the minimized DFA of long ways L1 using some property, directly can you construct the minimized DFA of long ways L2 or not, we will discuss now. Okay, so first let me construct the DFA for or minimize DFA for long ways L1. If I want to do it, I have to construct the minimize DFA of long ways L1. So what are the strings possible? We will write the smallest string possible over the long ways L1. Okay, it will be epsilon. Okay, where the number of A's are even, number of B's are even, means 0 B's can come, and there is no restriction on A's, so even A can be also 0. So even number of A's, B's, even number of A's, even number of B's. Meaning is that there is no restriction on the A's, so I am just writing 2 A's and 2 B's. Or you can take another small string as BB, and you can find A, B, B. Okay, A, B, 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 so on. So these are the sum of the strings possible in the long ways L1, and as we can find, there are infinite number of strings are there. This long ways L1 becomes an infinite long ways. So we will construct the DFA or minimize DFA for long ways L1. So how can we construct? We'll take the smallest string is epsilon. So if epsilon is there, what I can say? Your initial state will act as a final state. Now you take the another smallest string. The smallest string, another smallest string possible is BB. So from Q0 on B, you should accept it. Why I am writing? You can ask me, sir, till now when it is BB, you have written B here, on Q1 on B, Q2 you have reaching. But here why you have written? Why I have written is that if I simply write like this, lot of people can question me, sir, why you have written like this? You can write like this also. Now if you see this, what is happening is that it is accepting only 2 B's, but next time I can have 4 B's, or I can have 6 B's, or I can have 8 B's, because the number of B's are even. If I write like this, or if I write like this, what will happen? 1 B it is not accepting, 2 B's it is accepting. So even number of B's it is accepting. Suppose now I want to check for 4 B's. First B it is not accepting, second B it is okay because I want to access the 4 B's. Third B, fourth B. So 4 B's it is accepting. 6 B's also it will accept. So even number of B's it will accept. Now if it can accept the even number of B's, now what about the complete DFA? Whether it is a complete DFA? No, because there is no transition from Q0 on alphabet A. Similarly on Q1 on A we don't have. Now tell me one thing. A can come any times in the starting because there is no restrictions on the A. So on Q0 on A it can be even sometimes AA also I should accept because the number of B's here is 0. So on Q0 on A I should accept it. Okay. Now if you see that you saw a single B and you can see any number of A's, still if you see a B, even this string belongs to long ways L1. Why? The number of B's are even in this case. So after seeing a single B, you can find any number of A's, and after the any number of A's, if you still see the B, you should accept it. So I can simply say that as there is no restriction on the number of A's, you can simply keep the Q0 on A, you can keep a loop, Q1 on A also you can keep it as a loop. Now we will see the long ways which is a complement of L1. Okay, we will go for the strings which belongs to long ways L2. The smallest string is a B because here odd number of B's are there. Okay, and another one is AB, Okay, you can have 3 B's, you can have 2A, 3 B's. The simple restriction is that the number of B's should be odd. As the number of B's are odd, you can have a single B, you can have 3 B's, you can have 5 B's, all these things. So how I can write it? As there is no epsilon, take the small string, there is no epsilon is there, so your initial state may not act as a final state. So let me write it Q2 because I have taken Q1 here. So Q2, and I need to accept the single B because I will take the smallest string which belongs to long ways L2. What is the smallest string? A B. So from the initial state Q2, on taking the input alphabet B, I am reaching to a state called Q3, and as I need to accept this one, so I have made the Q3 as a final state. Now single B is accepted. If 2 B's comes from Q3, I will write here. For 2 B's I will not accept, for 3 B's I will accept. So if you see that it will accept the odd number of B's. 1 B it will accept, second B it will not accept, third B it will accept. Similarly, fourth B it will not accept, fifth B it will accept. So it is accepting the odd number of B's. What about the number of A's? There is no restriction on the number of A's. So the number of A's can be kept like this. So this is the DFA. Let me write it as DFA1, and this is a DFA2, or minimize DFA1, minimize DFA2. Okay, if you see this one, the minimize DFA1 consists of the accepts the strings where the number of B's are even, and this one will accept the number of B's are not even, or I can say that they are odd. The number of B's are odd, then it will accept it. Now we will see what is the relation between these two DFAs. Is it clear? If you can see that here the initial state, or I should not say the initial state. If you see that non-final states here, what is the non-final states? Q1 as made it as final state here. Let me write it here. The non-final state in L1 when it comes for the DFA1, okay, in the minimized DFA1 you have a non-final state. That non-final state when it comes to minimized DFA2, you made it as a final state. Is it clear? Let me repeat again. Here if you see that Q1 is a non-final state, that non-final state you made it as a final state here. If you see that remaining thing, everything looks same. On A it is going, A on A it is going here. Even B's are repeating like this. So everything is same. Only the non-final state in the minimized DFA1, when it comes to minimized DFA2, you made it as a final state. And the final state here in the minimized DFA1, Q0 is a final state here. When it comes to here, you made it as a non-final state. So final state in minimized DFA1, you will make it as a non-final state. If you can do it, you will get the minimized DFA of complement of the long ways L1. Is it clear? So let me repeat this. What are the statement I have given? If you complement the minimized DFA1, how can you complement the minimized DFA1? By converting the non-final states to final states and final states to non-final states, you will get the minimized DFA for the complement of the long ways L1. Is it clear? So complement of the long ways L1 is L2. So this is the minimized DFA2. If you see that here there is a final state, here they become as a non-final state, and non-final state they converted into final state. Okay, just for an understanding, I will take another example so that you can understand the concept in a better way. We will not keep the restriction on the B's here. We will simply make that, okay, L1 consists of strings where the length of the string, is divisible by 3. We will see now. Okay, if it is divisible by 3, means it should be properly divided by 3. If it properly divided by 3, then what you will get? string length of 0 you will get, string length of 3 you will get, string length of 6 is possible, string length of 9 is possible, string length of 12, all these things. Say I'm not keeping restriction on the either A or B, I'm keeping the restriction on the length of the string. So the length of the string, if it should be perfectly divided by 3, the length of the string should be 0, or it can be 3, or it can be 6, or it can be 9, or it can be 12, and so on. So let me find out what is this long ways L1 consists of the strings. So the strings consists or belongs to long ways L1 is, you can have epsilon, even epsilon is nothing but 0, so 0 can be divided by 3 perfectly. Now it can be A, B, B, because the length of the string is here 3. So I can say that you can find out all the strings whose length is 3. So how many strings you will get? 8 strings you will get. I will give some of them. Okay. So I am giving sum of the strings, and even you can find the strings whose length is 6. So whose length is 6, how many strings you will get? 2 power 6 strings you will get. Okay. So I can say that it is an infinite long ways. So if it is an infinite long ways, there may be a DFA or there may not be a DFA. If there is a DFA is available, what is the DFA? We will check it now. Okay. So as you have a epsilon. So if anywhere if you have an epsilon, your initial state will act as a final state. Okay. On A, on B, you are getting of length 1. Length 1 you should not accept. Okay. Length 2 should you accept? No, length 2 you should not accept. Then length 3 you should accept. So length 3 strings you should accept. So if you see that it is accepting epsilon, 1AB it is not accepting, means length 1 it is not accepting. Length 2 it is not accepting, length 3 it is accepting. Let me check it whether it is correct DFA or not. I will take one string ABB which belongs to long ways L1. If you take a string from a long ways L1, what my DFA should do? It should accept it. What is meant by accepting by the DFA? Take the initial state and parse the entire string. You have to reach to one of the final state. Let me see. What is the initial state here? Q0 is the initial state. So Q0 on A, you are going to Q1. Q0 on A on B, you can go to Q1. So on A, I went to Q1. Q1 on B, I have reached to the state called Q2. Q2 on B, I have reached to a state called Q0. Now, from the initial state, on traversing the string, I have reached to a state called Q0. Now, if you see that Q0 is also acting as a final state. If you reach a final state, what I can say? The string is accepted by the DFA. So, I can say that it is a correct DFA. Now, I want to discuss another thing. You have a long ways L2 which is a complement of long ways L1. So, how can you represent the complement long ways? Sigma star minus L1. Or I can say that it is not divisible by 3. I will write that the string length is not divisible by 3. If it is string length is not divisible by 3, what I can say? The remainder should be, if you divide any number by 3, you can get the remainder as 0 or remainder as 1 or remainder as 2. Now they are saying that not divisible by 3. So you should not get the remainder as 0. You should get remainder 1 and remainder 2. Let me write the strings which belongs to long ways L2. So the string length is not divisible by 3 means it can be of length 1 or it can be length 4, length 7 or length can be 2, 5, so on. Is it clear? So it will have of length, string lengths of 1. What is the string lengths of 1? It can be A comma B. Okay. It can have a, so these are the string lengths 1. It can have a string lengths of 2. AA, AB, BA, all these things. It can have a strings of length, of length 3. Okay. Length 3 is not accepted. Length 4 will be accepted. A, like that it will accept. Is it clear? So, long ways L2 consists of the strings which does not belongs to long ways L1. I can simply say that complement of long ways L1 is long ways L2. If I say that complement, the strings which belongs to long ways L1 will not be there here and vice versa. So we will now try to construct the minimized DFA for the long ways L2. As you have the smallest string a comma b, your initial state will not act as a final state. Why? Or I will take it as a Q3 to avoid the conflict. Your initial state Q3 will not act as a final state because there is no epsilon here. Because if you take epsilon, it will be divisible by 3. Okay? You should accept single A or B. Are you able to understand it or not? Q3 on A comma B, you should reach to a final state called Q4, which will act as a Q4 will act as a final state also. Is it clear? On second A and B, meaning is that if you have two A's, mean two A's or AB or BA or BB, you should accept them. So if you see that single A it is accepting, two A's also accepting, means length 1 it is accepting, length 2 also accepting. What about length 3? Length 3 I should not accept it. Is it clear? Are you able to understand it or not? Length 1 it should accept, length 2 it should accept, length 3 it should not accept. Length 4 it should accept, length 5 it should accept, length 6 it should not accept. Length 7, length 8 it will accept, 9 it will not accept. So it is correctly doing means it is accepting the strings whose length is not divisible by 3. So if you see the relation between these two DFAs, or I can write it as M1 and M2. If you see the relation between M1 and M2, the non-final state Q1 and Q2 are the non-final states are become as a final states here. Okay, the non-final states, if you make it as a final state and a final state, you made it as a non-final state here, and you did not change anything about the direction of this edges. Simply the edges are like that only. A on B here also it is there, A on B it is here, A on B it is same like that. But I am just making it as a final state as here non-final state. Okay, non-final states has a final states. Then I am able to construct the complement of the long ways which is accepted by this DFA. Okay, so I hope you have understood what is a complement of a long ways and what are the how can I construct the minimized DFA for long ways L1 and how can I construct the minimized DFA for complement of the long ways L1. I have given two examples. If you have any doubts or if you find some any interesting questions, you please give the questions in the or your doubts in the comment section. I will answer your doubts less than 24 hours. Thank you so much.